So you are being recorded. Sorry. Let me see if that's showing up. Any questions off of? You're okay on everything? 18, yep. And 3. Mm-hmm. Anyone else want to speak up for Abby?
C or like 17C.
17C. And 2. It's okay. Yeah.
I agree.
Yeah. Yeah, I actually was going to ask you that, but there was a note on your attendance. So yeah, go ahead. Are you good on these questions, or do you want to wait? Okay. All right, so let's look through some of these. All right, let me know if we end up adding some, so like as we go here. So hopefully 1 was okay. We'll go to 2 here. So log base 3 of the square root of 27. That's really big. Okay, so when if you try to do square root of 27, that's not going to work out very nice. Square root of 27 is not a nice number. So again, and we also don't know, we don't do a lot with roots and logarithms. So what I would suggest doing is switching it to exponential. First of all, like in terms of, like, right, this is log base 3 of 27 to the 1/2 power. Because remember, 1/2 and square root are the same thing. Now this is my strategy for it. There are other ways to make this work as well. And those of you guys who are gone, feel free to kind of follow along, do this with us. So this is one of our properties we learned yesterday, was that we can take that power and drop it down in front. And I'm going to put it in parentheses so we can kind of focus on this now. So that the 1/2 drops down in front as a fraction. So what I'm going to do now is I'm going to try and figure out what this would be. So I'm going to look at just that piece of it. The ghost apparently did not like the window shades on. Kind of creepy. All right, so log base 3. I was trying to get my glare off of my screen. All right, so we're going to do 3 to the x power equals 27. And so 3 to some power equals 27. 3 to the second is 9. 3 to the third is 27. If it goes up again, I promise the ghost I won't change it. All right, so x would be 3. So that's what this is. We can just replace that with 3. So we're just doing 1/2 of 3, which is 3/2 or 1.5 or 1 1/2, but we're able to rewrite it that way. So initially looking at this would be really tough unless you kind of break it down. And there's other ways you could do it, but that's probably the way I think is probably the most straightforward. If you got it another way, that's fine. So our answer is 3/2. Are we okay on 4? The base is the same, so you just end up with a power. 3. I skipped 3, sorry. I'll do 3. I would say 3 is the tougher one in comparison, I guess. But hopefully you realize that there's something we can do with our So again, there's a few different things you guys could do with this one. This is probably, I think, the most straightforward strategy, but it's what I thought of. It's kind of, and whether or not you think of it or not, whatever. So we learned yesterday that a division becomes subtraction. So we're going to separate this out as subtraction. So it's log base b of 1 minus log base b of b. Well, so each of these can kind of be simplified, kind of like what we did here. So I'm going to look at just this. So log base b of 1, I'm going to set that equal to x. So b to the x power equals 1. So any value, when I raise it to a certain power, is always going to equal 1. What's that x going to be in this case? So any value, raise it to this power, it's going to equal 1. It's always 0. So log base b of 1, so basically log of 1 of any base is always going to equal 0. And again, that's just trying to get used to remembering those things, because that, again, is talking about the fact that if I have 8 to the 0, it equals 1. If I have, 1,156 to the 0 power equals 1, it doesn't matter what I'm raising to the 0 power, it's just always going to equal 1. And that's what that's essentially saying there. Now this one, log base b of b, so we're saying b to the x should equal b, well that means x would have to equal 1. So we have 0 minus 1, and so in this case our answer is just a negative 1. So, I mean, it's basically like we taught you new language in the last, few lessons, and now I'm expecting you guys to be able to read, write, communicate with someone. There's a lot going on here, I know that, and there's a lot of little things that you have to remember, and they come more quickly to me because I've practiced them over the years. So, I know it's not as easy as maybe I make it seem when I explain it. You're like, oh, that's obvious now. It just takes practice. So that's why we're gonna kind of stomp the brakes a little bit here today and practice for another day of logs, and I'll throw in some other review stuff as well. Okay, so I was gonna skip down to 17C, but that would be skipping, so 5, 6, any calls for those? I don't mind it if we need them. Sure. Okay, so number 5 is trying to get used to the different notations we use, or the names we use. So it says 2/3, I believe, to the second is equal to 4/9. I believe they're just asking you to write this in log form. It says the logarithm base blank of blank is this. So again, it's getting used to writing log with a base and then what it equals. So it's just asking you to translate it back. So the base is always the base. So the base in an exponent with an exponent is always the same thing as down here. So base of 2/3 of, and we always are taking the log of the thing it equals, because the exponent is always over here. So they weren't really asking you to do much with number 5, just rearrange it and kind of fill in the blanks. Number 6 asks you to evaluate the log for a bunch of different values of n. I believe it goes up to all the way up to 9. So a couple different things you guys could do with this. I probably would not suggest trying to do a guess and check for a lot of these. A lot of these would probably be pretty painful. So you're basically just doing log base 2 of 1, log base 2 of 2, log base 2 of 3. Now some of these you might just know. Again, log of 1, anytime it's a log of 1, it's just always going to be 0. I know these two just cancel to be 1. I know that, but if you didn't, The other option is to actually just substitute that into your calculator the way we learned yesterday. So log of 3 over log of 2. It's going to be a decimal. But if you forgot that rule, and maybe this is more obvious when you see it this way, log of 2 over log of 2, those cancel to just be 1. Log of 1 over log of 2, again, that's just going to end up being 0. So these are going to be, some of these are going to be decimals, and then others of them are going to be whole numbers depending on the problem. So you're just you're changing that log. So you're doing log of n over log of 2, and you're just changing n all the way up to 9. It's just asking you to kind of keep plugging that in. Okay. All right, so skipping ahead then, number 12, we're okay with solving number 12. Speak up if not. Okay. That one I would switch to log form probably to do it. I was trying to do that one. 16 is like the continuous growth. And so again, watching out doubling, we want to set it equal to 2. 17C, I understand why that question. It's a really weird way to explain what they're trying to get you to notice there. So we're going to look at 17. You kind of need A and B to show you that. So it asks us to compute log base 12 of 98. And then B says log base 98 of 12. And then it says, the wording for it's really bad. Generalize the result you found in parts A and B. Like generalize, I guess maybe come up with a rule for it. It's kind of just trying to explain what's happening here. So I'm hoping that when you punch this into your calculator, you look at that and say, wow, there's a lot of similarities there, or there's a very strong correlation between those two. What's the math word for this? Do you guys remember? Reciprocal. It's just I know, who pulled that right out? Nice work. So it's just the reciprocal. So anytime, so what they're trying to get you to see is that basically if I flip the base and what I'm taking the log of, the answers are just going to be the reciprocal. So if I do log of 98 divided by the log of 12, it's like 1.845, sorry. And then the other way, log of 12 divided by log of 98, that should be the reciprocal of that one. So this is 0.54. I believe if you do 1 over, it should be the reciprocal. So if I flip this, so if I do 1 over this, it should equal that. They should flip back and forth. They're just reciprocals of each other. So what I'm trying to get at with that maybe, or what the book was maybe trying to get you to notice, is maybe if you're doing something like log base 3 of 1, that might not be it. That might not be a great one. Yeah, because that would be log. Let's not do that one. Log base 4 of 16. Log base 4 of 16 versus log base 16 of 4. So once I flip those, let's look at an easier example of that. This is 4 to some power equals 16. So log base 4 of 16 is 2. If these are supposed to be the reciprocals without having to do a ton of work, what should this one be? 1/2. So they're reciprocals of each other as well. So if I flip where the logs, like the base and what I'm taking the log of, that's what they're trying to get at for letter C. It's supposed to be a kind of interesting question, but if you're struggling to understand, it probably seems just overwhelming. All right, so let's look at number 18. This is I was just talking to Mr. Hatfield about this yesterday. This is a total math dorky thing that I love these problems. I like that it can, and that's a math teacher thing, that I love how it connects factoring to logs to, you know, just that we've kind of come full circle with why we had to learn certain things, or some of the reasons why we have to learn things. So I will always like these problems. So that's probably a hint that something like it would be on the test, because I do like them. Okay. So it says use definition and properties of logarithms to solve the equation. So we learned yesterday that addition of two logs of the same base, we can combine these. So we're going to do that. So I'm going to combine these two by using multiplication. Now, just because I can't stand putting the x on the backside, I'm going to do this instead. So I put it there because I want to distribute this in. And you could distribute from the backside as well, but. Okay. So this is why I'm at. You're probably like, that doesn't look any better than what we started with. It actually isn't that bad. What we can do here is we can rewrite this in exponential form. This is base 10. So 10 to the second is going to equal x squared minus 15x. 10 to the second is 100. And again, kind of full circle here, we're factoring again. So in order to solve a quadratic, we have to move that 100 over. So I'm trying to solve this by factoring. It equals 0 now. So I know it's going to be x and x. I want to multiply to 100, negative 100, and add to negative 15. What do we get? 20 and 5. I believe so, right? Negative 20, positive 5 will multiply to give me a negative 100, but add to give me a negative 15. So I set each of these equal to 0. Move the 20. We okay? Right? So x is 20, and x is also negative 5. Now yesterday we just made a quick mention that we can't take the log of a negative. So I put my answer back in here, and my log is negative, like log of negative 5. We actually can't use that one. If you tried to substitute that in and check it, it would give you an error message. So we throw out our negative, the values that make our logs negatives. Okay? So, and that's just like, if you forget that step, you're going to be okay. All right. So what we are going to do is, like I said, we're going to kind of take another day to spend on this. I did throw some limit stuff in our notes here, just to remind you some of that stuff, so we don't kind of forget that we needed to do that as well.